This is Miss Steele's Precalculus class, section 7.2. We're going to be talking about addition and subtraction formulas. So the addition and subtraction formulas you need to know are listed here. It's sine of x plus y equals sine of x times cosine of y plus cosine of x times sine of y. If you have sine of x minus y, it's going to be the same thing except there'll be a negative. So good thing to remember about sine, if it's sine of two values, if it's adding, you're going to be adding the sine times cosine plus sine times cosine, and if it's subtracting, you will be subtracting the sine times cosine minus sine times cosine. If you have cosine of x plus y, you will have cosine of x times cosine of y minus sine of x times sine of y. So when you take cosine of two values that are being added together, remember the cosine comes first and then the sign change. So it's cosine minus sine. And then vice versa, if you have cosine of x minus something, you'll still have cosine out in front, but then you'll have that sign change, so it'll be adding the sine of x times sine of y. So tangent of x plus y becomes tangent of x plus tangent of y, all divided by 1 minus tangent of x, tangent of y. So when you have tangent of x plus y, in the numerator you'll have an addition sign, in the denominator you'll have a subtraction sign. And then vice versa, when you have tangent of x minus y, you're going to be subtracting in the numerator and adding in the denominator. As we use these formulas more and more, you guys will become more comfortable with using them. So example 1, we want to either use an addition or subtraction formula to find the exact value of the expression. When it says exact value, that just means that we want something other than a decimal. So you do not want to plug this into your calculator. So thinking of cosine of 15, numbers we know that either add or subtract to 15 is that we know cosine of 45 degrees and we know cosine of 30 degrees. If we take 45 minus 30, that gives us 15. So cosine of 15 is equal to cosine of 45 degrees minus 30 degrees. So using our formula, cosine of 45 degrees minus 30 degrees is equal to cosine of 45 degrees times cosine of 30 degrees. And then we have a sign change, so it's plus sine of 45 degrees times sine of 30 degrees. So cosine of 45 degrees is in the first quadrant, and it's the square root of 2 over 2. Cosine of 30 degrees, also in the first quadrant, we have the square root of 3 over 2. And we have an addition sign, so plus the sine of 45 degrees is also the square root of 2 over 2, and sine of 30 degrees is 1/2. So now we just multiply our terms. The square root of 2 times the square root of 3 is equal to the square root of 6, and then our denominator becomes 4 because 2 times 2 is 4. Plus, and then we have the square root of 2 times 1, so the square root of 2 over 2 times 2, which is 4. So we have the square root of 6 over 4 plus the square root of 2 over 4. So writing this all together, we have the square root of 6 plus the square root of 2, all divided by 4. So now looking at example 2, we have tangent of 19 pi over 12. It is easier to work with degrees just because we can add degrees and subtract degrees in our heads a little easier. So we are going to convert 19 pi over 12 into degrees. We do so by taking 19 pi over 12 and multiplying by 180 over pi. So then our pi's will cancel, and we are left with an angle of 285 degrees. So now we need to think of angles we know. So we know tangent of 330 degrees, and we also know tangent of 45 degrees. If we take 330 and subtract off 45, we are left with 285 degrees. So tangent of 330 degrees minus 45 degrees is equal to tangent of 19 pi over 12. Using our formula, we have tangent of 330 degrees minus tangent of 45 degrees, all divided by 1, and now we're adding, we have a sign change, so 1 plus tangent of 330 degrees times tangent of 45 degrees. So tangent of 330 degrees is equal to the negative square root of 3 over 3. And tangent of 45 degrees we know is 1, so we have negative square root of 3 over 3 minus 1 in our numerator. And we're going to divide by 1 plus the tangent of 330 degrees is again negative square root of 3 over 3. And tangent of 45 degrees is 1, so times 1. So now we are going to multiply by the conjugate. So multiplying by the conjugate, we have 1 minus the square root of 3 over 3, or I'm sorry, 1 minus negative square root of 3 over 3, which is the same thing as 1 plus the square root of 3 over 3. Divide by 1 plus the square root of 3 over 3. So when we do this, we end up getting negative square root of 3 over 3 minus 1/3 minus 1 minus the square root of 3 over 3 in the numerator. And this is all divided by 1 minus 1/3 in the denominator. Simplifying this, we have negative 2 times the square root of 3 over 3 minus 4/3, all divided by 2/3. Simplifying this further, we are left with negative 2 times the square root of 3 minus 4 all over 3, which is just our numerator, all being combined in the same fraction. And dividing by 2/3 is the same thing as multiplying by the reciprocal, which would be multiplying by 3 over 2. Then you can notice that our 3's will cancel, and we are just left with negative 2 times the square root of 3 minus 4, all divided by 2. Simplifying this further, we can break up our fraction into negative 2 square root of 3 over 2 minus 4 over 2, which ends up giving us the 2's cancel in the first term, so we have the negative square root of 3, and negative 4 over 2 is the same thing as negative 2. So our final answer is negative square root of 3 minus 2. Looking at our next example, it says, use an addition or subtraction formula to write the expression as a trig function of one number, and then find its exact value. So if we have cosine of 18 times cosine of 12 minus sine of 18 times sine of 12, it's important to understand that the two cosines come first, so we know that this is a cosine formula, and since it's a minus, we know its cosine's always the opposite of what you see, so there's going to be an addition in the cosine, in the formula. So it'll just be cosine of 18 plus 18 degrees plus 12 degrees. So we know that cosine of 18 plus 12 is equal to cosine of 30 degrees. And cosine of 30 degrees in the first quadrant is the square root of 3 over 2. Looking at our next example, we have sine of 3 pi over 4 times cosine of pi over 12 minus cosine of 3 pi over 4 times sine of pi over 12. Since it goes sine and then cosine, we know it'll be a sine formula. And sine is always as you see it, so since there is a subtraction sign, that means we're going to have sine of 3 pi over 4 minus pi over 12. Now finding its exact value, we have sine of 3 pi over 4 minus pi over 12. In order to solve for this, we need a common denominator, which our common denominator will be a 12. So this is equal to sine of 9 pi over 12 minus pi over 12. So now we can just subtract straight across. 9 pi minus pi is just equal to 8 pi. So we have sine of 8 pi over 12, which we can reduce to sine of 2 pi over 3, which is just equal to the square root of 3 over 2. So for 3 and 4, we got an answer of square root of 3 over 2. Examples 5, 6, and 7 ask us to prove the identity. This is very similar to what we have been doing in Section 7.1, day 1 and 2. We're just going to be converting one side to the other. So let's start out with the messiest side. So we have cosecant of pi over 2 minus u. Cosecant is a reciprocal of sine, so we are going to rewrite this as 1 over sine of pi over 2 minus u. Now using the sine subtraction formula, this becomes 1 divided by sine of pi over 2 times cosine of u minus cosine of pi over 2 times sine of u. Now to simplify, we know that sine of pi over 2 is just equal to 1, so we're just left with 1 times cosine of u. And cosine of pi over 2 is 0, so we have 1 minus 0 times sine of u. So essentially we are only left with 1 over 1 times cosine of u, which is just 1 over cosine of u. And we know we can rewrite 1 over cosine as secant of u. So that's secant of u equals secant of u, and we successfully proved this. For number 6, we have cosine of x minus pi over 2 equals sine of x. So since we're already in cosine, we just need to use the cosine subtraction formula. This looks like cosine of x times cosine of pi over 2, and then we're changing signs, so plus sine of x times sine of pi over 2. So we still have cosine of x. Cosine of pi over 2 is equal to 0, so we have cosine of x times 0 plus sine of x times sine of pi over 2, which sine of pi over 2 is just 1. So anything times 0 is 0, so we are just left with sine of x times 1, or just sine of x. So sine of x equals sine of x, and we successfully proved that.